Is for the back of the virtual review. It's a calorimetry problem. So this one, the first one, number 4, you have a glass and you're trying to find the initial temperature of the water you're pouring water in. So what you want to do is you want to make a list again, and you want to make a list of like glass, and you want to make a list of the water, and you want to have all the variables in the Q, M, C, TI, TF, change in temperature equation. Q, M, C, TI, TF, change in temperature. So a glass with a mass of 300 grams and a specific heat of 0.49 joules per gram degree Celsius and a temperature of 25 degrees Celsius is filled with 75 milliliters, so that's going to be 75 grams because 1 milliliter equals 1 gram. And the final temperature of the water in glass is 27 degrees Celsius. So the final temperature is 27. And we know the specific heat of water is 4.18 joules per gram degree Celsius. Okay, now what we can do is we can calculate the temperature change of the glass by 27 subtract 25. That's 2 degrees Celsius. Now, here's what we can do. If we could get how much energy the glass, let's see, the glass is, let's see. It looks like the glass is warming up. So if we can figure out how much energy the glass has gained, we can figure out how much energy the water has lost. Okay, so the first thing we got to do is take this and do Q equals MC delta T for the glass. So for the glass, we got to figure out the Q. So we're going to do Q equals MC delta T, that's supposed to be an M. So Q equals 300 grams times 0.49 joules per gram degree Celsius times the temperature change of the glass. Okay, so the glass goes up by 2, so if I take 300 times 0.49 times 2, I get that the glass gained 294 kilojoules. So the glass gained 294 kilojoules. That means the water lost 294 kilojoules. Oops, I forgot to write the K, J. All right, anyway, so now for the glass, what we're going to do is we're going to solve for delta, or for the water, we're going to just solve for delta T. So if we have the Q equals MC delta T equation, we can just move that delta T, well, we want delta T by itself, so we want to move M and C down here. So we can get that delta T is going to equal Q over MC. By just moving M and C, they're all on the top, moving them diagonal. Okay, so our delta T is going to equal the Q for the water, 294 joules, divided by the mass of the water, 75 grams, times the temperature change, or times the specific heat of water, which is 4.18 joules per gram degree Celsius. So the temperature change equals, so 294 divided by 75 divided by 4.18. I get that the water changes, the temperature change of the water is about 0.94 degrees Celsius. Now, you could have put a negative in there, and then you would get a negative there. But I'm just going to tell you, a lot of people get messed up on the signs, so I'm just going to tell you to use your brain. So if we know the water temperature changes by 0.94 degrees Celsius, okay, if the glass warmed up, the water had to have cooled down. Okay, if the glass warmed up, the water had to have cooled down. So if it originally was 27 and it had to cool down, it had to be more than 27, so you got to add the 0.94. So the initial temperature was 27.94, or if you round to sig figs, 28 degrees Celsius. Okay, so the water had to cool down because the glass warmed up. Okay, so that's kind of how that one works. All right, okay, number 5. Okay, number 5 is a real algebra problem, big mess here. But anyway, basically how this will work is that the whole premise of calorimetry is the Q of the metal, the energy that the metal loses or gains, has to be equal to the Q of the water. Okay, now you got to read the problem. A metal with a specific key to temperature of 75 is placed. Okay, so the metal's hotter than the water. So the metal's going to cool down. What's really important is that you make the metal Q negative. The thing that cools down, you have to make negative. Now, what we have is we know what Q is equal to. So Q is equal to MC delta T. So now I'm going to write that for the metal here. So instead of writing the whole Q equation, I'm just going to put what Q is equal to. So MC TF minus TI for the metal. But because that whole thing, the metal is losing energy, that's going to be negative. That's going to be equal to the MC TF minus TI for the water. Now, I'm going to plug in what I know. Okay, a metal with a specific heat of 0.38, a temperature of 75, and a mass of 45. Okay, so here's the metal. It tells us that the mass is 45. I'm not going to use the units because it gets messy. And the specific heat is 0.38. All right. And the temperature initial, oops, why did that do that? And the temperature initial is 75. So TF we don't know, and we know that that's 75. That's going to equal the mass of the water, which is 25 milliliters, so that's 25 grams, times the specific heat of water is 4.18, times TF, we don't know what that is because the water and the metal will have the same final temperature, okay, and the initial temperature is 21. Okay, the first thing I'm going to do is I'm going to simplify this equation. So I'm going to take the 45 times 0.38. And I get 17.1. So I'm going to write that right here, 17.1. This whole thing is going to be negative, okay, times TF minus 75. The whole thing's still negative, okay, equals, so I'm going to take 25 times 4.18. So I get 104.5, 104.5 times TF minus 21. Okay, then I'm going to distribute. So I'm going to take 17.1 times TF, that's 17.1 TF, minus 17.1 times 75, so that's 1282.5, 1282.5, but that's minus still, okay, but this whole thing is negative, okay, equals, I'm going to distribute the 104.5, so that's 104.5 times TF. And if I take 104.5 times 21, so that's going to be minus 2194.5. Minus 2194.5. Okay, now I'm going to take this negative and I'm going to multiply it through. It's basically like negative 1. So I'm going to get negative 17.1 TF plus, because a negative times a negative, plus 1282.5. That's going to equal 104.5 TF minus 2194.5. Okay, I'm going to combine like terms. So I'm going to add 17.1 TF to both sides. And I'm going to add this 2194 to both sides. And basically, I like to deal in the positive. So basically, I'm going to take 2194.5 plus 1282.5, and I get, if I do this side, I get 3477. That's going to equal my TF's 104.5 plus 17.1. That's going to equal 121.6 TF. Okay, I want TF by itself, so I got to divide both sides by 121.6. I'm just going to move it diagonally over here. So if I take 3477 divide by 121.6, I get 28.6. So I get that TF equals 28.6 degrees Celsius. Now does that make sense? Okay? The metal is hot, the water is like 25. Is my answer in between 25 and 75? Yes. Does it make sense? Okay, the metal's heavier than the water, but the water has a higher specific heat, so the water's not going to warm up as much as the metal cools down. Yes, it makes sense, so I think that's the right answer. All right, that's it for that video.